Femtosecond pulse lasers have broad applications in multiphoton microscopy. This protocol can be used to fabricate a femtosecond all-normal-dispersion fiber laser that is compact, robust, and inexpensive. Compared with commercial solid-state ultrafast lasers, the laser produced in this technique costs much less because it consists of only commercially available parts. Also, fiber lasers do not need water cooling, so the size of the system is smaller. Last but not least, the fiber components do not require alignment, which makes the system robust to vibration.
Unlike commercially available systems, this laser does not have a cover to block unwanted beams. Experienced personnel are needed to assemble and operate the laser. Some experiments appear to be unreproducible because it is very likely to miss some untold details when following written instructions. In visual demonstration, the viewers won't miss anything.
Start by splicing single-mode fibers, or SMFs, in order to ensure proper performance of the splicing equipment before more valuable fiber optic materials are used. Strip approximately 30 mm of the fiber with a fiber stripping tool. If working with fragile fibers, a razor blade can be used to carefully peel off the buffer. Use a lint-free tissue with ethanol or isopropanol to clean the stripped fiber. A buzzing sound while wiping indicates that the fiber is sufficiently clean. Then, place the fiber holder on the fiber cleaver and make sure that the blade, fiber clamp of the cleaver, and the fiber holder are all clean. Carefully load the fiber.